that we can get the idea of what the question's like, slowly inch up to what the difficulty level needs to be. And then the other handout, questions vary from easy, 2 or 3 steps, to pretty difficult, 9 or 10 steps. We may not finish the other worksheet today, but we're going to go through all of this one together. Okay, so question 1 says that tangent times cotangent is supposed to be 1. All right, well, number 1, these are not true-false questions. We're not asking you if that's true. We're telling you it's true. The point of the question is for you to prove or show that it's true. So in order to do that, you've got to sometimes do algebra and sometimes plug in trig identities. The first few here will just be trig identities only. So you look at this and you say, well, okay, I know a different way to write tangent. So what could you substitute in for tangent? Sorry, so what are you going to say? Sine over cosine. I will admit that one of the frustrating things about proving trig identities is even though that's right, sometimes you might do that and it just may not be helpful and you have to erase it sort of. But if one person thinks of tangent as sine over cosine, what are they probably going to do to cotangent? Right? Hopefully that same person would be willing to say, okay, well, if tangent's sine over cosine, then cotangent's cosine over sine. And this is supposed to equal 1. Right, well now, so I've done the trig part of it. I've plugged in my trig identities. I don't have to prove how multiplying fractions work. Multiplying by cosine and dividing by cosine cancel out. Multiplying by sine and dividing by sine cancel out. So I've shown that the left side is 1, which is what the right side has been the whole time. So that would be one way to prove that. Now, most of these questions have multiple paths, and most of these questions that have multiple paths, one way is much more efficient than the other ones. You only need to find one proof. Okay? You only have to solve it one time. Except for question 1. I want us to actually solve this one 3 different ways. I want you to see that there's more than one correct way to do it. So maybe, instead of thinking of tangent as sine over cosine and cotangent as cosine over sine, maybe this person said instead, what's a different way to write cotangent? Okay, that's true, but the x minors don't really help here. Okay, so somebody else might use a reciprocal identity just on cotangent. And that's fine too. That also proves that the left side is 1. And even a third way for this question. Somebody else may even say, well, tangent is the same thing as 1 over cotangent. So if you want to go that route to show that tangent becomes 1 over cotangent, and then timesing by cotangent and dividing by cotangent cancel out. 3 different ways to go about the same thing. Always pick whatever you think is going to be the easiest way. Okay, so what kind of substitution? That's the only one I'm going to do multiple ways. I ask that you multiply again multiple ways. What substitution should we do for number 2? Okay, so we could use our reciprocal identity and change this to 1 over cosine. And now, you may not know if that's going to work at first, but write it down, see what happens, and if it looks good, great, keep going with it. If it doesn't look like it's helpful, then erase it and start over. That's going to happen sometimes. So, is this going to help us finish this one? Times cosine divided by cosine, 1 equals 1. Now notice, I'm not adding anything over to the other side, I'm not subtracting anything, I'm not dividing anything. I'm leaving one side alone the whole time. 1 stayed 1 all the way through. 1 stayed 1 all the way through. Okay. So for number 3, tangent times cosine is supposed to be sine. I guess, so don't write this down, but you could say cosine is 1 over secant. That's not wrong. It's just that if you do that, it's not helpful. So then you have to say, okay, that's kind of like a dead end. maybe instead of trying to rewrite cosine, I'll rewrite tangent. And, I hope you don't do this, but you could even for tangent say that it's 1 over cotangent, and you might say, okay, well that doesn't work. I gotta figure out something else to do. So, in this case, what would we actually want to plug in for tangent? Sine over cosine. It's enough to show that the left side equals the right side. So there's not a lot of work going on there. It's just one step. But the thought process behind it, you have to know your function identity, and you have to know it well enough that hopefully you can see that that's going to work, so that you don't try 4 different things kind of like that. You can be a little more efficient with it. Okay, number 4 looks to be about the same to me. If this worked in number 3, I tend to think, try that in question 4. Cotangent, I could try writing as cosine over sine. I don't know that it's going to work, but I've got to start somewhere. So I write it out. I see that the sines cancel, and that's enough. So I'm not using any algebra yet because they're all trig identities. I'm just making substitutions with what I know is true, what is always true, and that's what a trig identity is, something that's always true. Okay, so now let's slowly start to inch out to ones that are a little bit harder, because those were just one substitution there. Okay, so this one has cotangent, times secant, times sine, it's supposed to be 1. Right, so pick one of those, and we'll rewrite it. How do you want to write cotangent? So there's multiple ways. So let's say we just did that. Well, all of this stuff's being multiplied. So times sine divided by sine, you can go ahead and cancel those out. But I'm just not quite finished. Some of it went away, but I need a second step this time. Now this looks a lot like, this is question 2 now, right? I saw that changing this into 1 over cosine, plus those cancel. So the left side is in fact 1. So again, the point of the question is not to figure out if the left side equals 1. It does equal 1. The point of the question is for you to show that it equals 1. Yeah, well, and after some practice, I wouldn't do this in 2 steps. I would probably change this to cosine over sine. I would see that that's enough to get rid of this. And then I would probably just go ahead and change this to 1 over cosine because that would get rid of that. Yeah. Okay, so now we're going to mix in some algebra. If I've got 2 terms times 2 terms, what do you think that's probably going to do? Okay, well, what's the process called when you take these 2 times these 2? 4. So probably going to be 4. That's what it looks like. So 1 times 1, 1 times negative sine, sine times 1, and sine times negative sine. Okay, so for the first question, we actually had to use an algebra skill, not a trig skill. Okay, so I never know 100% sure that that's going to be what I need to do, but that's what my best guess is, so I'll do it. And then what does it look like we need to do after that? We have right terms, so go ahead and let those 2 go away. Okay, now we're close, but I still have to show somehow how 1 minus sine squared is cosine squared. So is there anything we know that relates those? You can't add anything to both sides because it's not an equation. But your reasoning why you want to do that should still be a hint. Why did you want to add that over? Okay. So the first Pythagorean identity, and you don't have to take this advice, but generally when I do trig proofs, I write the 3 Pythagorean identities down on the top of my page. I like this. I like having visual of those. I don't want to mentally try to keep up with that. So here's the first one. Divide them all by sine. And divide them all by cosine. So this one right here, you don't have to prove any of these. These are ones that everybody memorizes. Hopefully you memorize for your quiz today. And you get to use these. So if I rearrange this for 1, I subtract the sine squared over, 1 minus sine squared is equal to what? Okay? And I don't have to prove that that's true. I get to use that this is true. So in place of 1 minus sine squared, I get to say that that's cosine squared. So you're basically done, but you have to know your Pythagorean identities, and you have to know them well enough that you recognize that's what you're supposed to do there. Don't add the sine squared over. Just say that this is cosine squared. So cosine squared, I left it alone all the way through the question. Don't add anything over there. Okay, so if that worked in number 6, chances are that's probably going to be the thing we want to do in question 7. 2 terms times 2 terms. FOIL's probably going to work out. So go ahead and FOIL that, and then combine your like terms. You got this one on your quiz today, but even if you didn't, you're going to know it by the end of class because we use this about 50% of the questions. First Pythagorean identity, so sine squared plus cosine squared equals 1. So if I wanted to go ahead and solve it, you can either do this mentally or you can do it over to the side. 1 subtract over cosine squared. I can safely replace that with sine squared. Okay. Yes. Can you skip this part? Because those are conjugates, yes. Anytime you multiply something by its conjugate, the outer and inner part of FOIL will cancel. And so yes, mathematically, if you know that, I'm fine if you skip it. So we do that a lot in calculus, and you usually get the outer and inner both extremely messy. No one wants to write it, even though some people out and stuff. But try not to skip. I mean, that's okay, because that's kind of deceptive mathematically, because it's always true. But try not to skip your showing your work. That's really the point of these questions. Okay, the other big thing I need to warn you about is that a lot of times you guys will try to do this. You get to right there, you'll realize that this is sine squared, you know that it's supposed to equal sine squared, and you stop writing. But someone looking at your work, me grading this, I don't know if you know that sine squared. I hope you know it's sine squared. But your last step really needs to be that the left is the same thing as the right. Don't stop one step before. Looks like you got stuck. Okay, so one more. Like this might be a little bit overkill, but 2 terms times 2 terms. We worked on the last 2 questions. So probably going to be FOIL. Outer and inner will cancel. So even though I don't know that you need to see another FOIL question for distributive, FOIL is really just a special case of distributive. There is still a good lesson for you to get out of this. So get to this step. I'm going to write down some stuff, but you don't need to write this down. Okay. Let's say you get to this. Sometimes the best thing you can do, if you don't know what else to do, is you can write everything in terms of sines and cosines. Sometimes it's necessary, Like this is 1 over cosine squared. This is sine squared over cosine squared. Changing everything into their equivalent sines and cosines is a good tool to use, but you really should only do it when you're absolutely stuck. So if I did that on this question, I get that, and then I have to add my fractions together, which we're going to see in question 10 is a step that we need to do anyway. This one already has a common denominator, so that makes it a little bit easier. I can push these together in one big fraction. And then what does that make my numerator? Because that's the first Pythagorean identity. And then you can say anything divided by itself is 1. So you see that that works? And you guys will do this to yourself sometimes. That's completely unnecessary. I'm glad that you can do that. This was just one step from being done. Secant squared and tangent squared are related in one of your Pythagorean identities. Secant squared minus tangent squared is 1. So you don't have to prove that. You get to use that. But again, if you're not familiar with it, you're going to do this to yourself. You're going to add an extra 4 steps to your problem that are not necessary. And that's sometimes why the questions are harder than they have to be. Please really think about what your steps are going to be and if it's necessary. Changing the sines and cosines is the last resort for me. So the other 4 give you some different variation of some ideas that need to cross your mind. But I wanted to prove this one in number 9. Something that's obvious to me, but it's really only obvious because I've done all of these. What you need to kind of see is that this side has sine squareds and cosine squareds. I want them to only be sine squareds. So in other words, I want these to go away somehow. So the sine squared is probably fine. I'll leave it alone for a step. But not only do I want the cosine squared to go away, I really want it to turn into sine squareds somehow. I want it to get rid of this stuff I don't want and make it become stuff I do want. Well, cosine squared is the same thing as 1 minus sine squared. So this is just using that first Pythagorean identity. Now I'll admit, that's a little hard to see at first. And you really got to think about why I'm doing that. This side has sines and cosines, but I only wanted sines. So making this substitution gives me only sines. Well, if you happen to think of that as a strategy, then you're going to be able to finish it. Because to finish it, you just distribute and combine like terms. The rest of the question's not hard, but seeing to make that substitution just takes some practice. So I'm telling you for the first time. Also, you don't have to write this down every time. If you leave it blank a step or 2 or 3, it's assumed that this is just currently done. Okay, so sometimes that's a good approach to the question. Sometimes, like question 10, we need to add our fractions together. And what makes me think how I can see that I need to add my fractions together here is number 10 has 2 terms on the left and only 1 term on the right. And a convenient way to force 2 terms together is to get a common denominator and force them together. Okay, so this fraction is currently the sine of A over the cosine of A. And this fraction is currently the cosine of A over the sine of A. So we can only add and subtract fractions if they have a common denominator. So if this one has a cosine and this one has a sine, what is the first denominator need to have included? I can't just multiply the denominator by sine without also multiplying the numerator by sine. Sine times sine becomes sine squared. So I'm doing that in red so you can see what I included for the left fraction. What is the right denominator need? And if I want to include a cosine in the denominator, I need to also multiply the numerator by cosine. Okay, multiply the top and the bottom by the same thing to keep it in change size. So we do all that work to get a common denominator so that we can push it together with that common denominator. And when you're doing that, it's fine to be unsure if that's going to work out. But as soon as you write this piece down, you should start to feel pretty good about it, because the numerator is now familiar. First Pythagorean identity says that it is 1. And I've really just been doing the only thing I can think of. I haven't even really been looking at the other side. But now to know if I'm finished or not, I'm going to look over to the other side. And I'm basically done if I know my reciprocal identities. 1 over sine is cosine, and 1 over cosine is secant. So we don't have to add functions a lot, but sometimes we do. It was a way for me to get these two terms into one big term, like that inside this. Okay, with that being said, go in the opposite direction sometimes is a good idea, and that's what I want you to get out of number 11. If you compare this step to this step, I took two things with the common denominator and I added them together into one big fraction. But sometimes you want to split apart a fraction. You want to take a big fraction and split it up. So that's what I'm suggesting you to try number 11. You can put secant squared x over secant squared x as long as you put 1 over secant squared x. It's like I'm unsubtracting those fractions. And again, I don't expect everyone to know that that's a good strategy right away. But now that I've shown you that, let's see how it's going to work out. So what is all this going to simplify to? Because anything divided by itself is 1. If I use reciprocal identities, what would this simplify to? Regular cosine? Cosine squared. And now, as I said, even if you didn't know this for your quiz, which I hope you did, it's like the 10th time we've already used it today. 1 minus cosine squared is sine squared because of the first Pythagorean identity. So splitting apart your fraction, also a good idea. Sometimes that makes things just work out. Alright, and finally, so if splitting apart my fraction worked in number 11, I can consider splitting apart my fraction in number 12. So, any question that takes more than a step or two, you're never going to know if that's the best approach, but try it and see how it goes. If it starts to get too crazy, it seems like it's going to be too long, it could just be a hard question, or it could just be that you didn't pick the most efficient path. But if I did this becomes 1. Alright, now, for a second, I'm not going to write all the steps down here because I don't want to do this. But don't write this down for a second. I've got to show how this stuff simplifies. This is not a basic identity. I don't expect you guys to memorize what cotangent divided by tangent is. So, sometimes to show this, you might change this into terms of sines and cosines. Say divided by this in terms of sines and cosines. And then you can divide those fractions by multiplying by the reciprocal, and you're going to figure out that it's cotangent. And it's not that it's unreasonable, it's just that there's 3 or 4 steps that are not necessary. So the smarter thing to look for is I don't want to just give you the easy path just because I want it to be easy for you, but mathematics, we always aim for the most efficient. Kind of the same idea. This is cotangent divided by tangent. That's the same thing as timesing by its reciprocal. But what's the reciprocal of tangent? So this is really like cotangent times cotangent. You see how I'm phrasing it that way? Dividing by tangent is the same as multiplying by its reciprocal. So if you happen to notice that, Then you get to skip a couple steps. Then you got to do like what I was starting to do. Change this into sines and cosines, change this into sines and cosines, and divide your fractions. And 2 or 3 steps later, you'll say, okay, that's good. Alright, and then you could change this into sines and cosines, you could add your fractions, and a few steps later, you could finish the same thing. This, you can make the question harder than it has to be. The 1 plus cotangent squared is cosecant squared. If you have those Pythagorean identities at the top of your page, you should just glance up and you will see that okay, so some of those start to get a little bit harder. But there's a lot of strategies that often come up. Alright, so now let's look at these where the difficulty level is going to be a little bit more mixed.